hundreds of, maybe thousands of people can benefit from it every day. So it's worth it, and I believe for me, it's a chance to be able to have such a positive impact on a lot of people, a lot of colleagues' life. So I really enjoy that. So I have this background. Augmented reality, things like that are coming to life, and I even have some projects working on transformation. I'll be quick on that. It's not a wave. Wave by wave in parallel, and the more time flies and the more you got a larger number the beginning of internet trading to every homes. And so on. So the iPhone is 2007, so it's just a little bit more 10 years old. And when you look at how it shaped the world today, it's just crazy to see such impact, and how we are closely related to our smartphones today, and how it impacts the world, how we always look at these screens all the time. IoT at home, the same thing like internet. Of course, it started before, but since the years 2000s, it started to spread in every homes, and now you got 30% of houses in the US that have some Alexa or Google Home devices, and it's growing faster and faster. Because the more some people have it, and the more they convince the others to try it.
others said it was such a risky bet. And at the time, we learned that a lot about building scalable infrastructure and thought that other enterprises will benefit. And here we are now. Perhaps another example is Kindle. I don't know if you have a Kindle. I guess.
Unlike what happened to our parents and their parents, is changing all the time, which means we won't have only one job. We have to learn all the time. Vital to be able to learn all your life and evolve this way and help the others to do the same. In this change, the first aspect is the consumer-centric part. And yeah, you got a great example tomorrow morning with Amazon keynote about that, how to bring a new consumer-centric approach, and of course data mindset, because it's been yeah, about 10 years that everyone's saying data is the new gold mine, data is the new oil and whatever, but it's great to say it. Now change the process in the company to be able to manage all those data during all their life.
As you can see, you have different sites, and not all sites are launched to experiment.
If you like to record videos like I do with a green screen behind me, well, this is actually not a green screen, this is a gradient background, but you can see
This is a message to all streamers.
With a free program called OBS. So stay tuned, I'll be right back.
instance. And it's not often you find designs that have the ability to scale that much. And so looking at the layered structure and the functionality of the layers and the interfaces between them and the stability of those interfaces is actually an important lesson to learn. There's a price to pay for the layering, but it has allowed for a substantial amount of expansion in the technologies of the networks underneath and the applications that go on top. And so there are lessons to be learned from understanding the design and the implementation. And so I would encourage students to look at it from both ways, because they're going to live in a world which is filled with internet until something else comes along.
And so what would you say? Is it what's always fascinating is that you really have
How I did it. First, go to wix.com.
C'est la même chose. Non, Et là, c'est la même chose, il faut juste que tu fais soin que c'est pas dans la bouche, et ça, c'est dans le joint. Et si c'est parfois dans la bouche, c'est pas possible. S'il fait toujours dans la bouche, voilà. Avantage, quand ça commence, tu pousses juste ça, oui. Et voilà. Et où la pendule? Elle est où quoi? La pendule. Comme ça. Ah, oui, elle est en. Donc, oui, je pense qu'on peut commencer. Oui, je pense qu'on peut juste commencer. Okay, welcome back. Can you hear us? Yeah, can someone open the mic and say something so that we can test our audio?
Yes, we can.
Okay, perfect. Yeah, we can hear you. Wonderful. Very good. Okay, good. Then, as said, so the session right now is about the internet. And the internet is, I would say the internet is the backbone of our society. This is something we can discuss, even though probably all the guys sitting here are agreeing with that. And I would like to start with an interview that is about 15 minutes with one of the two who created the Internet Protocol suite, IP protocol and TCP protocol. And this is Vint Cerf, and he invented or he created these protocols together with Robert Kahn. And he received the Turing Award, I don't know in which year. For that, the Turing Award is like the Nobel Prize for computer science, because you might know there is no Nobel Prize for computer science. And therefore, the Turing Award was created, named by Alan Turing, also a very important and interesting figure of computer science you should definitely be familiar with. And yeah, let's start with the video, and afterwards we'll discuss a bit. And as said, it's not a discussion only among us, but you are highly welcome to jump in, ask questions, and discuss with us. Yeah, so let's start with the video.
Now, it turns out
Went.
yeah,
Nice having you here.
it's a pleasure.
One of the fathers of the internet.
One of them, anyway. Remember, there's a lot of them.
That's right, but you're one of them. Very good. So what would you say to students? So why is it important to study and explore the core technologies that drive today's internet?
So there are several reasons. The first one is that the internet is everywhere, and if you have anything to do with any kind of engineering that involves the use of the net, you should understand how it works and what its weaknesses and what its strengths are. But looking at it as a purely engineering design, it's worth looking at because it has scaled by a factor of 1 million over the course of its existence. And it's not often you find designs that have the ability to scale that much. And so looking at the layered structure and the functionality of the layers and the interfaces between them and the stability of those interfaces is actually an important lesson to learn. There's a price to pay for the layering, but it has allowed for a substantial amount of expansion in the technologies of the networks underneath and the applications that go on top. And so there are lessons to be learned from understanding the design and the implementation. And so I would encourage
so we have a little bit low audio, so we'll just try to fix that and restart it, because we can actually not hear anything. Let me just check how we can do that.
Simplification of the different layers, because to me what was always fascinating is that you really have this pure sense of encapsulation and abstraction that you say. It somehow works. So,
well, the idea was that each layer would rely on the layers below for some functionality which it didn't have to implement. So, for example, let's take the Internet Protocol layer, which, by the way, was split out from the original uniform TCP. And we split the IP layer out here. We could talk about it. But the point now is this Internet Protocol layer has some very, very simple properties. It behaves like electronic postcards. So the layers above write a postcard, address, and that's some content into the IP.
Like that, it will work, right? Okay, so let's restart. Sorry for that, but now we can also hear it. Do I have the share still on? I guess not. I'll share it again. Okay, good. Let's start it again.
Yeah, I have an idea. That's right. What would you say to students? So why is it important to study and explore the core technologies that drive today?
So there are several reasons. The first one is that the internet is everywhere, and if you have anything to do with any kind of engineering that involves the use of the net, you should understand how it works and what its weaknesses and what its strengths are. But looking at it as a purely engineering design, it's worth looking at because it has scaled by a factor of 1 million over the course of its existence. And it's not often you find designs that have the ability to scale that way. And so looking at the layered structure and the functionality of the layers and the interfaces between them and the stability of those interfaces is actually an important lesson. There's a price to pay, but it has substantial expansion in the technologies of the networks underneath and the applications that go on top. And so there are lessons to be learned from understanding the design and the implementation. And so I would encourage students to look at it both ways, because they're going to live in a world which is filled with internet until something else comes.
Would you say that more the abstraction or the simplification of the different layers?
The IP and the lower level networks.
And all this is what you will explore in the course. They will also see how the packets travel from A to B, that they don't necessarily travel back the same path, how the TCP mechanisms are working. And so as you briefly named it, so was it thought to be combined at the beginning? So the TCP and the IP and then...
Actually, what happened, that's a very interesting question. We started from about the time when I wrote this first paper. We had in mind just this one end-to-end protocol, source host through multiple networks, and gateways between the nets to the destination. That was our goal. And we wanted reliability, we wanted retransmission, we wanted duplicate filtering, and so on. About 2 or 3 years into this work, from 73 to 75, we realized that we were also going to have to support real-time communication, packetized voice, packetized video, packetized radar, and so on.
So there was already voice that time?
Oh yes, we were experimenting with packet voice and packet video very, very early in this one. This was being done for the Defense Department, and it was going to be used for command and control. Command and control involves voice communication and, with computers now, data communication, video. So it had to support all of that, and we were confident that we could make it. You can packetize anything, you can digitize. But it turns out that TCP has this property that it really wants to deliver everything in order, and it doesn't want to lose anything. Well, imagine for a moment that you're trying to do a voice communication, and a packet gets lost. It takes time to retransmit the packet. Then you can't play the speech out until that packet turns out. It means you introduce longer and longer latency as packet loss occurs until finally you're talking to somebody online. Well, in command and control situations, real-time interaction is very important. So we decided that we would split the IP functionality of TCP out. So that's just pure packet carriage, and it's low latency because there's no attempt to retransmit the IP. We put the user datagram protocol adjacent to TCP and said, okay, if you want low latency, go down the UDP path. But it's lossy, it's potentially lossy. So in a voice communication, if we lose a packet, it sometimes comes out as a pop or a click or something, and the other party might say, I'm sorry, I didn't hear that, please say it again. But the retransmission is done in the context of the conversation. The latency has not increased. So that's why we split that layer out. It was a strong argument about real-time communication that said we had to support both things.
That's how many computers did you have in mind at the beginning? Because you started that with 4 computers, if I'm right?
Actually, when we started the internet design work, it was 1973. This was 4 years after we turned the ARPANET on. So by the time 73 was around, we probably had 50 or 60 or maybe even 100 computers working all. But not full build.
How does it seem like that?
The
old designs were so great that they're still running.
When we did some calculations to try to figure out, how many addresses, how many destinations we need. And so we said, we were thinking globally at the time, because we knew the military didn't have to operate anywhere on the planet. And so that's why the address space is not nationally oriented. It's not like the telephone system. We figured the Defense Department had to be able to operate wherever it had to go, and it couldn't possibly have to get permission from the target country, especially if you're invading that country, to respond to it. So, say, excuse me, am I allowed to invade you? That's not how this works. So we said it's true, it's a topological. So the first question we asked was, how many networks? We said, yes, how many networks will there be per country? We just finished building the ARPANET, and that was not an inexpensive thing, so we thought, well, maybe there'll be 2 per country, just because there should be some competition. And then we said, how many countries are there? And we didn't know, and we didn't have Google to ask, so we guessed at 128. This was in 1973. Now there's 193 countries. So then we said, how many computers per country, or per network, rather? And there, at the time, most of the computers were big, expensive machines that were in air-conditioned buildings, and they didn't move around. But we said, well, maybe 16 million, because that's 24 bits. And 128 times 2 is 256, so that's 8 bits plus 24 is 32 bits of address space. And if we could densely populate the addresses, it's 4.3 billion terminations. It sounded like enough to do an experiment. And I thought that if the experiments worked for internet, that we would then do a production design. That's not what happened. What happened is that it escaped out of the research environment into the public around 1989. And so we've been running the IP version 4 design for all this time since 1983. In 96, we realized that we were going to run out of address space because of the proliferation of computing devices, Ethernets, and so on. And so we developed IP version 6, 128 bits of address space, and for the last 20 years, we've been trying to get everybody to implement that. We're slowly getting there, and there is evidence of significant penetration now, especially with mobile apps and smartphones, because they're using what's called LTE, long-term resolution, and most of them are using IPv6 addresses rather than IPv4. So with the Internet of Things coming along, I think there will be pressure in the manufacturing of the Internet service providers. Yes.
All the stuff, so if people want to stay with it before, they will still find ways. But you would say like IPv6 is well designed, and so it should be really works.
And it works. We run V4 and V6 for our application. The reason it's important is because we they're very proud of the debugging files in the market. And when crypto is something industry one. This is kind of sort of projection that you really want to have anyway, and it's not involved in address translation. We never wanted advance. I mean, that is not something that was designed. Neither were firewalls, interesting. And although the firewalls are, they are not a solution to everything because you can walk around the firewall. In fact, the machines that are inside at least we have evidence. So more and more, and it's the original model of hosts on the internet, but it had to protect itself. It had to decide whether we're not communicating with someone anywhere on the internet. We have to go back to that rather primitive, because in many ways, accessing something, it's likely for the sense.
So security was more a topic, like saying, okay, you chose those numbers and take care of those security. And
well, in fact, we were thinking about security, even though many people weren't remembering it. So we had, in fact, a project that developed packetized script very early in the 1970s. But some of that work was classified because of the equipment that we were using. So I can explain that to most of the people. That goes with applications. But the idea there was to have a platform encryption, which would deal with the traffic analysis or private traffic. And then higher level end-to-end crypto. Packetized crypto is tricky because you have to be able to decrypt out of order if you really want this to be. That's a non-trivial step compared to the usual point-to-point that people are accustomed to. So there was some work involved in that. The protocols, including RFC11, when we spoke about how do we do crypto, it didn't speak to the specific key generation and key management mechanisms because there were actually a variety of different choices. The early days, we had key distribution systems, which would distribute symmetric keys. Now, of course, we have public key crypto. We can use that for key distribution. Ironically, the public key crypto idea was published around 1976 by
so cut the entires on the video.
who were my colleagues.
You can cut the entires
The trouble is, there was no implementation. It was just a great idea. Then, some years later, 2 or 3 years later, the RSA offers some of the other exchanges, but by that time, we're basically standardizing the internet. So we can get it out there. And so if you get the chance to make use of the key crypto incorporated into the architecture at the early stages, but it's retrofittable. And of course, people are using this all the time with HTTP. So there's lots that we can still do to the internet to improve its ability to resist various forms of attack, to deal with service attacks or attacks against operating systems. And most of the big bad problems that happen in the net are not down at the network level. there ought to be applications for operating systems that aren't protecting themselves, which is why I had always thought, even in the beginning, that most computers on this internet thing would have to be protecting themselves by saying, I won't talk to you if I don't believe you're an appropriate party, so please authenticate something. And one way to do that is say, I have a clue that you have, so it must be okay. Say, code or something.
So yeah, so if you want to know about the thing we were talking about and more things, take part in the course.
That's a really good idea.
Shake hands.
I never watched them again. Yeah, right.
That's a gesture we don't see anymore today.
Yeah, that's right. That's right. Okay, so we heard that the audio was not working at the beginning. Sorry for that. We were also not monitoring the chat because we put us on mute. Yes, the summer school is everywhere. Okay, good. So, yeah. Yeah, so if you did not hear the sound, you had the link in the chat, so thanks for posting it. I will also send an email again, because it's really worth watching this video. This is also why I wanted to watch it together with you, because it's just amazing to hear, for instance, that already at the beginning in 1973, they had command and control with voice. This was in the interview something that I did not know, for instance. Okay, I noted down a few questions, and first question to you, Laura. When you're saying that the internet is a great design, would you agree or disagree, and why?
So I will say that it's a great design because it succeeded for almost 40 years, and you have very few things that survive at a period of time in computer science. So it's originally a good design. What I disagree with Vint is that at the beginning the internet didn't work. So when they try to promote datagrams, at the beginning you have some collision storms, which means that you didn't have flow control in the network, and it makes that network not really variable, or it was an experiment compared to other technology that were using circuit and was working. So it was not so easy at the beginning for the internet, and there is a big guy that nobody talk about, which is Van Jacobson, that introduced some flow control mechanism in TCP, and it saves the internet. If we didn't have that, we will never talk again now of internet.
Okay.
So just to tell you why IP is a nice design, and maybe we can go back after that on the architecture. It's, you know, that we had a lockdown a few weeks ago, and from one day to another, you change your traffic flow on your network, and then you go from watching Netflix to
at the office to watching Netflix.
No, in your home, and you go from Netflix to Zoom. So you change totally the nature of the flow, and you didn't have to change the architecture. So that's something that is very, very reliable. If you compare to other technology that we say, I will create something specific for video, something specific for voice, where you have, and then when you want to change it, it doesn't work. Here you have a neutral network that do what you ask for.
Just to add a bit more, I must say that I liked what he said about the fact that it was an experiment, that they didn't intend to make a worldwide network. They just wanted to test some feature. Of course, they had some ideas of making something to work, but it was experimentations, and also try and see if it's working. That's very an interesting approach you even in the PhD that you are doing, you should always have in mind that there is ideas and then experimentations and then come back on the way you thought it will work.
Mm-hmm. And what is also interesting is that he said, like, they created it, rolled it out, and so at one point in the video he says, like, and then we thought the real task would begin because we would design the right thing or the real thing, but then it was already adopted and the people were using it and so on. Yeah, very good. You said, Laura, that there were other internet designs like Token Ring and others which would have had different features.
In fact, if you look at layer 3 protocols, you had IPX, which was something designed for home office networking. You have SNA, what was more for bank, and you have X25, or what was more for long communication. And all of them were better than internet. But they were designed for a specific task. And when you want to do interconnection, it was not possible.
Which triggers with me the question, Internet of Things is the topic of our conference. So there we also don't have interoperability at the moment.
So I think what was something that Vincent said at the beginning is that internet was everywhere. It's not true. Internet is everywhere on computer, but not everywhere in any kind of equipment, small equipment. So there is a huge effort now to port this internet to some very constrained environment in a secure way, of course.
But is it desired to do that? To have the end-to-end same or similar protocols running?
I think end-to-end is something very important for security. If you have not end-to-end, you have to trust someone in the middle.
For security, I agree, but for having the IP, for instance, until the end device and not using more specific protocols.
I think it's possible. We prove it with header compression, so we can put IP in 1 byte.
Yeah, I would say even that we, as the society, tried to have things connected with a dedicated network, but it didn't last because if you have to develop something new each time you have a new hardware or a new application, it's not possible.
Yeah.
So again, it's like Laurent said, interoperability and interconnection are the keys.
Yeah, and this was also why I was raising this, because for the Internet of Things, I would say we still don't have it because we still have too much heterogeneity. So when we are in the domain of the sensor networks, it might be that we have some standardization, but then when we come to cameras, to heating controls, to blah, 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 it's still a path to go. Plus, it's the inhibitors of different vendors wanting to protect the market and also different applications where you have specialized protocols. But this is exactly what you said with the banks and the office networks and so on, where you also had like specialized networks, and in the end, something that was less specific functionality, but therefore one thing that fits more or less all was the one that was winning because there was the adoption. And maybe for the Internet of Things, we are on the way to something similar.
So yeah, the Internet of Things is not internet. They use internet to communicate, but they are not internet-like interoperability. So it means that right now, if you look at system designer, they produce the sensor and they produce the cloud application. So it means that they have a global system that uses some way to exchange information, but it's not the internet. Internet is two people that don't know each other and can talk together. So it's what we have to do for IoT. If you want to have something massive, you need this because you cannot control everything.
Irritated because Christian was writing that there's a bug. There's something broken. I don't know what he's talking about.
Do we have questions from students?
Yes, there is a question in the chat. from, I don't see, Nahi. So maybe you just unmute and pose your question.
Yeah, you can just unmute and ask the question.
Yeah, it was not a question, but it was just a comment that imagine the notion of constraint devices back in 75, 76. How would the IP stack would look like? It was. I'm not sure if you are able to, but I wrote.
Let me just switch.
It's just a comment rather than a question.
Could you repeat?
I mean, I was saying that imagine if we had the notion of constrained devices back in 75, 76, and how would the IP stack look like? I mean, it's not a question; it's just a comment from the video, right?
If it is it what is written in the chat? The question is if you had constrained devices back in the 75, would the IP look like the same?
I don't think so. Because now we're experimenting delays that are worse than the one at the beginning of the internet. So.
You two are doing a lot with standardization. So, what would you say is the importance of standardization?
It's important because if you don't do it, you have a lot of different solutions that doesn't interact each other, and it creates complexity. So I will say that the internet is too easy, and you can create what you want on top of it. And so if you don't structure that, you go to a lot of diversities. So you have to take some control and to force to use some structure, and this way you increase interoperability. I would say that in the beginning, when you have internet, it was a fight between computer scientists and internet and telephonists or that were doing something else. Right now, I think we have more a fight with computer scientists, because computer scientists say, okay, we can use a JSON format, I can exchange everything in the world with my JSON format, and I don't care about standardization. But if you do that, you don't have interoperability, and you just talk to the people you know. And standardization is a way to talk with people you don't know.
Yeah, the term without standardization would be isolation. You build the thing for yourself only, and you are not able to share it with everyone.
And you have to reinvent the wheel. For example, if you want to make security, you have to be sure that you're a security expert and all these things. And if you go to standards, then you have stronger people that are stronger than you that have fought to that, and you can reduce the result.
When we talk about the interoperability, on which layer of the internet are we? Is it on the semantic layer? Is it on the physical layer? Is it on the routing layer?
Well,
or their equivalents on the Internet of Things, where Laurent always says we are layer 5+ anyway.
Well, I would say the notion of interoperability for Internet of Things is the way that if you are in the internet with a computer and you want to talk with what we call a thing or an object, then you don't realize it. So it means that you have interoperability at all layers, excluding, I would say, the technology you are using, because this is very for the local communication. But then at IP, the transport layer, the application layer, it must be somehow compatible. It doesn't mean that they will use the same. You can have a gateway in the middle that will compress, for example, the IP. But the important thing is that you can build a standardized IPv6 packet and send it to an object in its own network.
Well, what are the limitations of the internet today? What would you say is the biggest limitation? So do we have enough bandwidth? Do we have low enough latency? Do we have enough data, or not data formats, but communication protocols to reach all these specialized devices that we have? Is it something totally different?
I don't see any limitation because it's something very simple. So it was difficult to reach something simple, but we have something simple. So you have, for example, Chinese people that try to push a new version of IP and saying we have now holographic communication, so we need something that goes faster. It doesn't imply a change in the protocol. You just have a layer 2 that is faster, and you adapt TCP, you adapt things, but you can follow this thing. So that's not an IP problem. They say you have new satellite like Leo where you need routing, but it's a new routing protocol. For example, when you go to Internet of Things, new routing protocol have been developed. If you go to data houses where you have you store your data and all these things, you have also new routing protocols. So if you have satellites, then you will have new routing protocols. So it's the adaptation. So what is important for IP is not to be specific for something. And if you keep these genericities, then you can evolve in all the ways. So for me, if you don't change the physical layer, for example, if you say I will now send neutrinos or have quantic networks, maybe then you have a change in the way the network will behave. But if you continue to use the network as we do, you can increase the speed, you can reduce the energy consumption, you have a lot of flexibility on the protocol.
What would you say is the biggest challenge? Do you agree?
Well, yes. I was about to say it's very hard question, and I don't think I would opt for the answer. There is no limitation. I was trying to find one.
Okay.
But maybe just what I saw at the IETF, for example, the evolution for the last, I don't know, 15 years or something like this, is that even this, the IETF is the organism that standardizes the internet. So all the protocols are made there. And maybe what I see there, it's the complexity of more personnel involved, more people want to add a new protocol or new something, and sometimes it's getting hard to see what is really needed and what is not. Because as we say, what we need is some generic protocols that then you can use and adapt to your needs. So sometimes it's not very easy to see what's the benefit for the global internet.
Okay, maybe I interrupt here. We have some questions in the chat. So Andrew Gini, you might ask.
I'm scrolling back. I forgot what I asked. One second. So I was wondering, what is the impact of 5G on IoT devices or internet usage? How does it change anything?
It depends. If you look at regular transmission, there is no change. If you look at IoTs, then the change is that to have non-IP communication. So it means that you, as I said, it's a more computer scientist approach where you send data to some point and then you switch to MQTT or to HTTP post, and then you send information to the cloud. So that's a big change. Personally, I don't like this evolution because it's something that breaks interoperability. And we see it with LoRaWAN. You have a lot of connector. You have everybody design his own cell or payload. And so it's very difficult to make things exchange. But the drawback is say that IP is big. And if IP is big, then you cannot send it on very constrained network. And we have proved that it's not true because we can do very, very strong compression for IoT because the traffic is very specific, is very well known, and so you can reduce a lot the errors. And this way you can design your own format for your specific usage.
It's true that it's very difficult to use IP on constrained device. We must say it's a hard problem because we want IP, but at the same time, the technology and most of the time the memory of the devices, you cannot afford to use standard IPv6, I would say. So this is why there are currently two choices, I think, either to compress or to get rid of it.
I had another question. How can we make internet usage environmentally less polluting? I mean, I've heard that, you know, watching 2 hours of Netflix, for example, is equivalent to 1 year of your fridge consumption or energy consumption. So another question is like this, really, is it because of the bandwidth of the internet or the data that it can consume that is all this happening, or is the storage of the data that's causing the problem? What exactly is causing this environmental damage? Was that clear?
I didn't catch totally the...
So no, I mean, I wanted to know, in your opinion, how can we make internet usage environmentally less polluting? Could you hear?
No, we didn't, because there is and to be honest, Marc Oliver's shoes make some noises. So it's can you repeat the question?
You're asking what are the major costs of the internet?
No, I have no idea. Can you hear me now? Am I audible?
No, the problem is rather the sound, because it's...
Yes, we have a lot of echo.
Yeah. So just try once again. Maybe we hear it then.
How can we make internet environmentally
Friendly.
more sustainable?
Okay. So it's a very good question, because the internet is really a huge footprint of what we have today as energy usage. And so my answer would be what the companies are also doing. So put the data centers underwater, for instance, something that Microsoft is doing, because you need less cooling, because cooling is one of the biggest things that you have. You can also look at Google, Amazon, Facebook. They're inventing new cooling solutions to get rid of that. You have hot and cold areas in server rooms and so on. So this is definitely something. In addition, of course, renewable energy. The good thing is that the connections through fiber are at the speed of light, and therefore you can also move the data centers far away from where you have people. You can move them to dams where you have water. You can even install cloud or edge data centers into windmills, like the wind farms we have. You can install it there. And this means you can use a lot of renewable energy and thereby reduce the energy footprint. So this is one dimension I want to mention. Another dimension is the production of the IT stuff and also the management of the waste that you have when you look at smartphones or you look at electronic products. But IT products are probably a big part of the electronic products that people have today. Plus, they have very short life cycles. When you think about these smartphones, for instance, they have a life cycle of less than 5 years, I would say, because then they're outdated. The processors are much faster. You cannot use it anymore. What happens in Europe? Well, the things are sold and sent, and then they often end up in Africa, and not even in landfills, but people are manually removing then some of the parts from it. They are destroying the environment there. So there's a huge range of problems. But there's also a lot that can be done. In the end, I would say what is the most important is that the people are aware of that they want some changes to have, and the people is us, so it's each one of us, and that we bring it into the political debate, that we say, okay, if you want to be voted, you have to take care of this issue, And we as taxpayers are willing to pay for that because we want to protect our planet, because it does not come for free. And those people who decide, they decide in the end based on the voters, because otherwise they are not voted anymore. And therefore it's super important that we express wherever we can that it's important to do something. From the technical side, it's possible to do something. So there, I would say, there are things, of course, where we don't have a solution yet, but the internet or the electronic industry we have today could be much, much more environmental friendly if we would be willing to pay for it. So this would be my comment to it.
I agree. It's a premier value chain. It means that you want everything free. So since we want everything free, then of course the money has to come from somewhere, and it's more about tracking people, about and if you look at the traffic generated by all the tracking, and when you go to a newspaper page and you get maybe 1/10 of the information is what you want, and the rest is a lot of tracking, a lot of cookies and all that
advertisements.
Stuff. And so it's more a problem of business. If you were paying for something, then you will not have all this tracking, or you will not have that.
And this is also to your sustainability question. This is also something important, because when you look at the amount of emails that are spam, when you look at the amount of traffic that is produced just by advertisement, is huge. So if you would get rid of this, this would significantly decrease the energy footprint that we have there.
But spam is an effect of to have a very cost-effective and efficient network. If you have to pay 1 cent per packet, then you will have no spam.
Okay, that's good. Let me follow up there. Net neutrality. So I want to illustrate it as an example. I was in Portugal 3 years ago, I guess, and before I lived in Germany, you have a plan for internet, and then you get like whatever, a gigabyte, or you got 200 megabytes for 10 euros a month, or for 20 euros a month back then. And then I came to Portugal, and there it was like very strange offers to me, because it was like, okay, you can pay 6 euros and then you get WhatsApp for free flat rate, Facebook flat rate, and whatever mixed flat rate. When you buy another packet, it costs something different, but you get 3 other services for free. And this is exactly not net neutrality, because this is like you have certain offers that are prioritized, or that are then monetarily prioritized in the sense of that they are free, and others you have to pay, which is something that is against net neutrality. Net neutrality is something that is super important in the internet, because something like Google could not have emerged if the internet would have been restricted. And today, if you would want to create something like Google, you might have problems, because Google especially created, and Facebook also, and Microsoft probably also created their own internets that allow them to offer services that others can just not offer, like shortcuts. They have faster links, they have their own infrastructure, and so on. So yeah, with this introduction, net neutrality, how is it? Is it a problem? What is your opinion to it?
For me, it's not an IP problem. It means that IP can create some closed structure like Facebook, and you can do Tor networking on it. So the protocol by itself allows you both of them. So that's the beauty of things. And then you have the usage. The usage is not a protocol problem, it's a society problem. And so, but technically, the protocol has been can evolve in both ways.
Yeah, sure. But this is like this is a technician point of view. It's like, okay, so my protocol is not restricted, but of course the internet is not so someone has to pay for it, and as someone has to pay the routers and someone has to pay the energy, this someone has control what is allowed to run over the universal protocol that you can use for everything. And
now for me, the big problem comes more from, so you're right on that, and I'm a technician, so I would say that we have to design protocols that are doesn't block the evolution of the network. And the other thing, the problem that we have right now is that we have no more IPv4 address. So when you want to create a service, you cannot put it in your garage because your garage will have a private address, and so you cannot create a service. So you have to go to either in a cloud and say, because they have still global IPv4 address, or you build it on top of some application given by Facebook, Google. So here you have a limitation. I cannot run a server in my home or easily. So that's the problem. IPv6.
Why can you not use IPv6?
Me, I can, but
so if you would say the adaptation of the IPv6 is not yet.
So IPv6, when IPv6 will be there everywhere, because if you don't, and then everybody doesn't have IPv6, so you cannot talk to the rest of the world. But if you have a possibility to have your server at home, then you can change the business model and put your mail in your home, and you buy just a program that manages it. Right now, you cannot do it, so you have to go to the cloud.
Okay, this is a very interesting point of view that I did not face before. Saying like, okay, the limitation of the IPv6 addresses is preventing businesses to spawn, and it's a realistic one. So it's a very interesting point of view. Thank you very much for that. Well, what would you say about net neutrality?
Well, it's not the way internet was thought, of course, and it's business driven. So now that you have so strong operators or application provider, they feel they can do whatever they want, and one of their objectives is just to increase business. And yes, this is a risk, I think, for the internet. And as we said here, as a society, we should take care of this problem. It's very important that, for example, for what concerns us at the European scale, that there are some measures that ensure net neutrality, because internet is not built for that. It's the opposite. It's the openness and the way everybody could deploy something.
A follow-up to that, we start with you this time. Would we need to reinstall net neutrality? Would we need that the internet is something like a road that the state is maintaining, and we don't have an open market for internet providers? That it's like a right, like the right to water, that everybody has an internet connection and the state is providing that. Do you think it would help?
Probably yes, because you know it's always a very delicate situation where you have the state that mandates some private companies to do something and to play by certain rules, and then you have other players that come into the picture that are not really controllable by the state itself. So I would say yes. You know, it's especially in France, they talk about, they know that some people are away from internet access or good internet access. So yes, it's a good idea actually that it's something that is taken care of with the states.
Do you want to add something? If not, I have a follow-up question.
No, continue.
Okay, so you said you're the technician, and my question to you would be, are opportunistic internet routing mechanisms, for instance, something that can help reinstalling this net neutrality, because they are taking away the power a little bit from the providers of saying, okay, I block you? And related to this question is also mechanisms like the Great Firewall of China, where you have elements that block, which is an extreme element now, but providers also have, like, depending on their tier level, they will either forward your traffic or not, and then you have better or worse traffic conditions.
So, thank you for this question. First, net neutrality is something quite strange, because the network is not neutral. It means that IP network has not been defined to broadcast things, but to make equilibrium point-to-point communication. So when you want to talk to many people, then you need an infrastructure. And this infrastructure is not network. You need CDN or anything. So for me, net neutrality is not this. It's more, I can put any new services on the network and it will be, I will succeed to deploy it. So that's more this that is important. So for the Chinese people, I don't understand why they are not doing, for example, to change their DNS routes. And if they change the DNS route, they change all the addressing of the internet, and they can deploy a new internet without changing the protocol. So you don't have to develop something else. You can run on what you want, but a network is more or less ideas. So when you look at a new protocol, don't look at the packet format. There is no interest. Look at how addresses or values are assigned in the network, and then you will understand how it works. So identifier and locator are very, very important.
Do we have another question, Christian?
Yes, we have. So Philip had a question. So maybe you ask it now.
Yes, thank you. So hello, good evening, everyone. So my question was regarding the comment which was made by Mr. Cerf about the point where the host is responsible for own security and has to protect himself or herself. So my question is that, like, is it actually possible nowadays that the user only himself or the host at the end can only protect himself? Because when you look at the networks nowadays, we see quite a complicated layers of security mechanisms trying to protect the users, and still not always is actually possible to protect the host. So is this part of the design which was maybe omitted, or how it evolved over time, or maybe we are there, or what is kind of your opinion to that?
So let me just rephrase your question if we correctly understood. So your question is, we observe that the host is responsible for taking care of the security, and you want to know now if with today's internet, one can still say it's up to the host to protect himself, or if the internet is so complex that this is not sufficient. Is that the question? Okay.
Correct, yeah.
So my answer is that the thing that you can protect is your own domain. So that means when you are the host, then you can protect yourself the best because you do not rely on others. Because otherwise you have to have collaboration, and when they do not collaborate, then you cannot have security. And the next question then is, what does it mean to secure oneself? So when I want to secure myself from intruders, I think I will be able to do that. It might be complex, but I will be able to do that. When I want to protect myself against network-based attacks like denial of service, then I cannot do it on my own, because a denial of service means people are just pushing so much into my connection that my connection is not working anymore. And obviously, when my connection is not working anymore, I cannot do much alone. So with that, I need someone at a more powerful position in the network to protect myself, for instance. And this would be the two dimensions of my answer, that I would say everything I can protect myself with, I should do, because I should not rely on others to implement mechanisms. If one day we would have standardized security through the entire path that is especially also auditable, so that I can really prove that the security is happening, this will be good, because it would take a lot of computational effort away from me. Then I could get rid of some of the tests that I'm currently doing, and for these networked things, I need partners in the internet. This will be my answer. Do you have something to add?
Well, maybe just a word on the physical attacks as well, because there is not only the protocols themselves. I mean, if you are running a service and if you are using, for example, wireless communication, it's quite easy for a pirate to come and interfere with your network, and then you don't have any communication anymore. So you can easily fight your network, and there's not much you can do at the protocol or implementation layer. Or there's also this branch of work on the hardware security itself, where you can find some information just looking at the hardware. So yes, there are definitely different dimensions, and one should really consider all the threats and see what can be done, giving the level of criticality of the application and the service.
Mm-hmm.
Want me to answer?
If you want.
Yes. No,
it's not mandatory.
Yeah. No, I think you don't have all the tools to. So we talk a lot about encryption. So encryption is a way to protect, but that's not enough. We need monitoring. We need to survey, to look after the traffic, and you don't have. We have also to isolate things, to not have everything in the same domain. And in some places you can do it, but in your home it's not possible, because if you rely on a device provided by your network provider, you don't have all these tools. So it's difficult to isolate, because there is also a trade-off between auto-configuration and isolation. So that's not that's easy to do. But I will say also that most of the attack also come from bad operating systems. So you have a lot of...
Even though this is mutual, I mean, the installation base obviously attracts attackers, because it's just rational to attack those that have most installations.
Maybe just a story I heard in a conference, but it was very funny. He was a specialist in security in a very big company. And he told us the story about the best way to infiltrate a big company network. And he said, just go to the parking lot, you spread USB key everywhere, and you will have at least one employee that will put it in his computer.
Yes. Yeah. And this brings us back to this Stuxnet thing. When you look at it, this is also what they used there, because they were air-gapped, the machines that in the end were attacked. Do we have another question, Christian?
Yes, we have another question by ArianeGroup. So yeah, you have the word.
Yeah, can you hear me now? Is it better?
Perfectly.
Okay. No, my question was about the total blackout. Do you think that'll ever happen? And if it happens, why would it happen? Or, who would be responsible? Like no internet for the whole world.
Sorry, the topic was what?
Blackout.
Blackout. Okay.
Blackout.
Okay, good.
I think.
Okay, a very, very good question as well. And the question is if it can happen, or why it did not happen.
No, if it happens, who would be responsible, and why would it happen?
Okay, yeah. So I would say it's highly unlikely that it would happen, that you have a global stop of the internet because of the design of the internet protocol. So
it's distributed.
It's distributed, and we already had. So why do I say that? Because the internet, it grew from something with a handful of computers to what we have today, with all the additions that Laurent was talking about. So it's not that this what runs today is a protocol from 1973. So there are cool mechanisms that are there. And with the billions of computers that we have today, this system is still running. We have attacks like when you look at BGP, the protocol that is used for controlling the routing over the internet. There are every year, probably more often, countries that are like, okay, yeah, we don't like our people to use a certain service, or we want to sniff on them. And they do a reconfiguration of this protocol that takes care of where your packets travel, because they want to have, for instance, all your YouTube or Facebook accesses. And as they are a country, they can do that. So they do that, and they do it poorly. And suddenly all the traffic to YouTube gets routed to, there was one incident in Pakistan, for instance, where this happened 10 years ago, probably, which we do in our lab course. And even though this was the case, not even such a major, and this is a major thing because it's really in the heart of the internet. This is in the heart of where the routing happens. Even this did not manage to create major damage. There was still the possibility that people could access even YouTube. There was some disconnections because they may manage to get some of the traffic, but still the network was so robust that it was working. And why is that? Because the system is built for disruption. It's like if you cut the lines, the routing algorithms are converging, and if there's one line lasting, you will get through this line. And the internet is spanning the entire globe multiple times. Therefore, for almost everywhere, you have more than one route to go. Therefore, I would say it's highly unlikely that the internet will break. The second question, who will be responsible? This is a very difficult one because the internet is not under one authority. So there is no central authority that is running the internet. There are internet providers that are together in communities that are collaborating, that participate in the standardization Laura was talking about, to have the interoperability. And yeah, so there would not be, it would not be possible to say like, okay, there's the one who's responsible to get it running, for instance. Again, if someone manages to break it, it will be probably quite easy to localize where this happened. But I don't think it could happen. What do you think? Can we have a blackout?
I agree with you in the sense that it's a distributed system. Nobody has a global control of the network. So if you're a major network administrator, you have a domain and you can control your domain, but then you talk with interaction with other domains. So nobody has a global view of the network. From the DNS point of view, the route is also very widely distributed. So it's very difficult to kill everywhere at the same moment. So you can attack some part of the network and some part will fail, but not all the network.
Mm-hmm. Do we have another question?
No, that's it for the moment.
I can ask if no one is asking.
If you want to ask a question, go ahead. Yes.
Actually, I was wondering about the urban-rural divide, right? We were talking about internet access. Can you hear me? Am I audible?
Internet access, I heard the first word was again cut. Really sorry for that.
Okay, is it better now?
Can you say it again?
Was it better now?
No.
No.
Okay. I have no idea what's happening. Okay, I'll try. I was wondering about places where there is no infrastructure for internet, like in rural areas. The new thing that is mobile internet, right? Or hot air balloons and things like that, where companies are experimenting in order to provide access to internet. So I was wondering, what do you think about this? And you think it's better to invest in infrastructure like in developed countries over there, or what can we actually do?
Okay, that's also a very good question. So it's about the infrastructure and that there are sometimes no cables or dedicated connections to people. And one point that I also noted goes also into the direction of your question, which is this satellite internet that is currently getting launched. So there's the very active Elon Musk who's launching it. There are different other companies. Yeah, what do we think about it? Is it a good thing? Is this a solution? Should we rather invest in fiber to the home, even in all undeveloped countries? I don't know, I could start, but I can also let you start as you like, but I can say something you want to start. Okay, so or you start?
Oh, good.
Okay, so what I would say is that even in Germany, it's the case that in some rural areas they are not connected. And the reason is that the telecom companies that would have to install the cable, they just don't want to do it. There were communities that were getting founded to create fiber internet, which were paid by the neighborhood, because the company did not have an incentive to do that because they did not expect enough revenue from installing this thing. Why do I say that? Because in less densely populated regions, like we have them in Africa, for instance, it will most likely be not economic for sure, but also not necessarily make sense to have the cables installed also for other reasons when you think about earthquake regions and so on, where this could be a problem. And therefore, I would say that the wireless communication technologies are definitely something that is highly valuable. So you were talking about the mobile internet. And that is also increasing speed and efficiency and range and quality and so on. And therefore, I think it definitely plays an important role. The satellites are something very interesting because they are funnily also promising for developed regions faster internet than the cables. And so to me, this is also an interesting technology. As plus point, as minus point, it's really polluting the space because they don't have a super long lifetime and you need tons of them. So it's a nice technological challenge again. It's also nice when the technology is there, but it's coming back to your earlier question, also a problem of sustainability. So now I put some inspiration to the whole.
I think you're right. I don't understand the business model for satellite coverage because where you have people who have optical fiber, where you have poor people that cannot pay, then they will not pay for that. So for me, SpaceX is more because it's not very expensive to launch this right now with very more satellite, and when you have few kilos more in your rocket and you launch this satellite just for fun, and you will see what happens with it. But the business model is quite strange for that. So if you have maybe new application, there is, for example, for IoT, it could be good because if you want to monitor some space, a location where you don't have any network, so satellite will be a good solution. But where you have coverage, infrastructure is much our terrestrial infrastructure will be more efficient.
Okay, good. So time also advanced, and yeah, I thank you very much. It was a very interesting panel, and it was also a quite broad range of topics that we covered actually, which is also good and clear because the internet is ubiquitous. It's everywhere and it's in everything. Okay, then yeah, thank you very much for joining us for this session, and see you tomorrow at 10 o'clock for the next poster session. See you tomorrow. Bye-bye.
Bye.
Thank you. Bye-bye.
Bye. Let's make a group picture. Valet, could you take a picture of us sitting? Okay. Because then we can post it. We can post it afterwards. Where is my photo camera? With the masks. Without, I mean, we are far enough apart. Or we go to prison. We have to measure. Good. Thank you very much. Merci beaucoup. Oh, il fait super froid ici.
Oui, non, il y a trop froid.
Et je pense aussi que l'audio est juste coupé parce qu'il est trop tard.
Ah, tu crois, non?
Non, je crois que oui. Oh, je te dis quelque chose.
Ils savent pas faire.
Non, si ça serait coupé, ça serait pendant les heures de cours.
J'étais dans le bureau de Thibault à 8 h et ça a coupé le Wi-Fi.
Ah ouais?
Ça a coupé le Wi-Fi, c'est quoi ça?
Non, nous, on a pris nos clés parce que les gardiens ont fermé les portes et on ne peut plus rentrer dans le bureau.
Quoi?
Ah,
Si,
j'ai
mais
pris
attends.
les clés.
Ah ouais, mais on peut retourner dans le bureau, non?
Oui, mais il faut la clé.
Ah oui, oui.
Who was the guy who asked questions?